Prove that the midpoints of the sides of a quadrilateral with vertices at the four vertices coordinates of the four vertices are given form the vertices of a parallelogram. So let us begin. So we begin by considering a quadrilateral A, B, C, and D. Let us suppose that the vertices, the coordinates of the vertices are, so A is going to have the coordinates 1, 7. B's coordinates are -6, 0. C's coordinates are -1, -9, and D's coordinates are 4, 1. Let P be the midpoint of side AB, Q be the midpoint of side BC, R be the midpoint of side CD, and S be the midpoint of side AD of the quadrilateral. So we're going to join PQRS to form another quadrilateral. So we obtained a quadrilateral PQRS. Our goal will be to prove that PQRS is a parallelogram. Okay, so what we can do first, let's try to obtain the coordinates of PQR and S. So we'll begin by first obtaining the coordinates of the vertex P. So coordinates of P, that's very simple. All we have to do is use the midpoint formula because P is the midpoint of AB. So that means to find out the x coordinate, we're going to take the sum of the x coordinate of each of the endpoints of A and B. So that's 1 added to -6. So that means we have 1 minus 6 and we're going to divide it by 2. To find out the y coordinate, we sum up the y coordinates of the endpoint. So that's 7 added to 0 and we're going to divide it by 2. So that means we have -5/2, 7/2. That's going to be the coordinate of point P. Similarly, we can find out the coordinate of Q. So Q is going to be, so that's the midpoint of BC. So we have -6 minus 1 divided by 2. And the y coordinate will be 0 minus 9 divided by 2. So that's equals to -7/2, -9/2. Coordinates of point R, so that's going to be equals to, now we have 4 minus 1 divided by 2, 1 minus 9 divided by 2. So 4 minus 1/2, that's simply 3/2. 1 minus 9, that's -8. -8 divided by 2 will be -4. And coordinates of point S, so that's going to be equals to, so we have coordinates of point S, that's going to be 1 added to 4 divided by 2, and the y coordinate will be 7 added to 1 divided by 2. So we get 5/2, 7 plus 1, that's 8. 8 divided by 2, that's going to be 4. Now we have the coordinates of the vertices of the quadrilateral PQRS. So let's redraw our diagram. Now, in order to show that PQRS is indeed a parallelogram, we'll show that the length of PQ equals the length of RS and they are also parallel. Similarly, we'll show that the length of the side QRS equals to length of side PS and they are parallel to each other. Let's try to obtain the length of PQ first. So PQ, we can obtain the length by using the distance formula. So we'll take the square root. Underneath the square root, we need is the difference of the x coordinate. So that's going to be, we'll start with -5/2. And then from it, we are going to subtract the x coordinate of Q. So that's -7/2. We're going to get +7/2 whole square. And add it to the difference of the y coordinate. So that's going to be 7/2 minus -9/2. So we have +9/2 whole square. Now when you compute this value, this comes out to be equals to square root of 65. Okay, so let's also find out the value of the length of the side RS. So that's going to be equals to, we'll take the square root, underneath the square root, so we'll take 5/2. So that's the difference of the that's the x coordinate of S, and from it subtract the x coordinate of R. So that's 3/2. We're going to square it and then add it to 4 minus -4. So that means we have 4 plus 4 whole square, and this is also going to give us a value square root of 65. So here we have obtained that the side PQ equals to side RS. So they are of equal length. Now let's find out the slope of, we're going to name this as number 1. Now we'll find out the slope of side PQ. To find out the slope of side PQ, all we have to do is you take the ratio, and in the numerator we're going to take the difference of the y coordinate. So we'll start with the y coordinate of P, so that's 7/2, and from it we're going to subtract the y coordinate of Q, so that's -9/2. Then in the denominator we'll have to compute the difference of the x coordinate. So here we'll start with the x coordinate of P because in the numerator we started with the P point. So here we have negative 5 over 2, and from it we're going to subtract the x-coordinate of q, which is negative 7 over 2. Fine. So this will be equals to, we have 7 over 2 added to 9 over 2. So that's going to be equals to 16 over 2, or simply 8, divided by, so here we have 1. So that means slope of line PQ comes out to be equals to 8. Let's find out the slope of the side RS. So that's going to be equals to, so in the numerator we take the difference of the y coordinates. So we have 4 minus negative 4, divided by, in the denominator we have the difference of the x coordinates. So that's 5 over 2 minus 3 over 2. So this is also going to give us a value 8. Now clearly we have obtained that slope of line PQ, that's equals to the slope of RS. And this means that when the slope of two lines are equal, that means the line PQ is going to be parallel to line RS, or we can simply say the side PQ is going to be parallel to RS. So let this be 2. Now from 1 and 2, we have the two sides of the parallelogram are equal in length and they are also parallel to each other. Similarly, we can show that QR will be equals to PS and they are also going to be parallel to each other. So let's write down the other condition as well. Similarly, we can show that QR will be equals to PS and QR will be parallel to PS. And thus we can say that PQRS is a parallelogram. So hence we have showed that the midpoints of the sides of the quadrilateral ABCD, when we join them, the quadrilateral that it forms is actually a parallelogram. Hence proved.